The second part of this presentation about Permafrost 101 will focus on land use planning. Land use planning must consider permafrost because permafrost stability is directly affected by human perturbations and constructions. There are many challenges to take into account in the land use planning in Nunavik. First of all, there is a serious housing shortage in Nunavik. The presence of permafrost also significantly complicates the designs of infrastructure and buildings, and land use planner must cope with different challenges such as a changing Arctic climate, a thawing landscape that brings a lot of permafrost degradation processes, a context of remote areas and limited resources and availability of equipment and workers, a short construction season, which bring a complex work schedule. There are several geomorphological processes in the Arctic that are permafrost specific and that can be observed throughout Nunavik lands. These processes respond directly to climate variability, which complicates the task for land use planner regarding the development of communities and the conception of long-lasting and sustainable infrastructure for Nunavimut. The key for a safe and sustainable development of Inuit communities is to adapt to the technical challenges posed by permafrost and to the particular terrain conditions in each village that can be quite different between each villages. Let's see why do infrastructure and buildings have such a big impact on permafrost. The answer is because of the heat transfer. Permafrost likes the cold. We will see shortly which construction techniques are possible to use to limit the heat transfer from the buildings and infrastructure to the ground. The stability of the infrastructure and the bearing capacity of the ground depends on permafrost conditions. And permafrost degradation, such as thaw settlement, landslide, or thermal erosion, directly leads to a loss of the bearing capacity of the ground and affects the stability of the infrastructure. Within the same village, different soil types may occur, with permafrost conditions and ice content in the ground varying from one superficial deposit to another. These conditions also depend on the terrain conditions, such as if there is vegetation, the slope, the drainage, the occurrence of natural hazards, and so on. Foundation types and infrastructure design must carefully be engineered to suit those local conditions and take into account the particular context of each villages. Among the different construction practiced to preserve permafrost, there is the ventilated space between the ground and the building. This ventilated space prevents heat transfer from the dwelling to be transferred to the ground. It also allows wind to blow beneath building and prevents snowdrift to accumulate. Regardless of the type of foundation that will be chosen, it is important to have a ventilated space between the building and the ground to allow air circulation. We can see here that the house on the left is built on stilts or tripods with adjustable jacks on a gravel pad above the ground. We can see that the permafrost is well preserved. On the right, the concrete slab foundation directly on the ground and without any mitigation techniques deteriorates due to permafrost degradation, water accumulates, and the concrete slab collapsed. Another practice that may help to preserve the foundation is that the gravel pad must be installed 1 year before building the house. This delay allows the active layer to rise up into the granular material and thus stabilize the permafrost in the gravel pad. The blue dotted line is the permafrost table before the construction, and the gray part is the active layer. When we install the gravel pad 1 year in advance, we can see that the permafrost table rise up in the gravel pad and stabilize. Also, on medium and steep slope, a large granular fill will be conducive to the formation of a snowbanks, which accelerate the degradation of permafrost at the edge of gravel pads and increase water accumulation. And the snow cover insulates the ground and prevents heat from being extracted from the ground. The temperature of the ground warms up. Permafrost is therefore degrading and water is accumulating. To better adapt to topography with less gravel, a good option is to use piles foundation. There are different types of piles foundation. The pile foundation significantly reduces the use of gravel while adapting to a very irregular steep topography. Since there is a ventilated space between the building and the ground, it also allows wind to blow beneath building and prevents snowdrift accumulation. It uses less gravel and is really effective on bedrock outcrops. Another way to adapt the topography with less gravel is the ground preparation. One way is to use cut and fill. Cut and fill is a method to level the ground by excavating and backfilling the excavated material. So we excavate local material and we use this local material to fill and adapt the topography. Combined to ground preparation by the use of cut and fill, we have to use slope stabilization to avoid drainage problems and accentuation of the occurrence of various geomorphological processes such as slope destabilization, like landslide. There are multiple mitigation techniques to preserve permafrost. Here is two other examples. The house on the left has a concrete slab foundation with thermosiphons. Thermosiphons are used to extract the heat from the ground beneath the building and keep the permafrost cold. The slab therefore remains intact. The house on the right is raised above ground and the weight is distributed over the different bearing points using a three-dimensional foundation with multiple bearing points. To have more information about these foundation techniques, I suggest you to read the Guide to Good Practices about Housing Construction in Nunavik. In this guide, the Chapter 5 is focused on foundation designs on permafrost. That brings me to talk to you about the various tools that are available to support decision-making about foundation types and location of community developments in Nunavik. First, as we saw earlier, there is various maps that are available that have been produced by the Centre d'études nordiques for different projects with different government ministries. We have the permafrost distribution that is locating the different permafrost zones. We have the permafrost thickness map. We have the superficial deposits map. The superficial deposits are directly related to permafrost because their properties, like the grain size composition and the different layer of soils, determines the properties of permafrost. It is the superficial deposits properties that will determine what is the ground ice content and what is the sensitivity of the ground to be deformed when it thaws. So from this map was produced the permafrost condition maps. The map of permafrost condition classified the terrain according to the ice content, the soil texture, as well as the approximate thickness of deposit over the bedrock. It also gives insight about the active layer thickness regarding the different permafrost conditions. From the superficial geology and the permafrost condition map was produced the construction potential map. This map defines which sectors are stable for construction, which ones are subject to uncertainty, and which ones are unfavorable for construction due to the presence of thaw-sensitive permafrost in the short term due to the poor foundation designs, or become problematic in the long term due to global warming. It also presents the foundation types and designs that can be used regarding the different superficial geology type and permafrost conditions. Another useful map is the map of natural hazards. This map presents the sector at risk from hazards such as landslides, avalanches, floods, or coastal flooding, and so on, that needs to be taken into account in the land use planning. Another useful resource that I presented quickly earlier is the Housing Construction in Nunavik Guide to Good Practice by the Société d'Habitation du Québec. As I previously said, the Chapter 5 of this guide is dedicated to the foundations on permafrost and review the basic concepts of permafrost, but also the different foundation types to adapt the foundation design to the frozen ground in a sustainable manner. In the same line of thought, here is another technical guide, this one produced by the CSA, so the Canadian Standard Association, for infrastructure on permafrost with climate change consideration. On the right, here are some examples of the chapter in this guide. To conclude, here is even more resources that could help anyone interested in land use planning on permafrost, and those various resources are covering topics such as land use planning on permafrost, and also to where you can download reports, maps, and data about permafrost in Nunavik. Thank you for watching this video. We hope that this short introduction to permafrost and land use planning implications was useful to you. Don't hesitate to join us to the period of question. We will soon reach out to tell you the details to attend to this web meeting. Thank you, ᓄnaauᵉ, and talk to you soon.